All right, so let's go over this one real quick. I know that the first instinct for many people is to try to create a ratio here. But remember, if you take a ratio anyway, you still have to cross multiply, don't you? So let's just go straight to the multiplication. Here you're going to go 4 times 7, 28, is equal to 5 times x. Divide both sides by 5. X is equal to 5 3/5, or what is it, 0.6? I like the fractions better.
I don't know.
Nobody likes decimals. They're too hard to work with.
Never deal with fractions.
Fractions are amazing.
Is your thing too frozen? I never know how it's eaten. Stop.
Okay. I wanted to address the broken circle. And I think the person that was broken was me. I was playing around with Geometry Sketchpad because I wanted to prove to myself some things. And I think our angle kind of looked like this, correct?
Yeah.
Yeah, and it was like angle 5 was here somewhere. It was something like that. I actually went down further.
That's a different one. Look.
Yeah, it kind of went like this. This is from the first circle. It did this, something like this.
Wait, this is a different circle. Look.
Well, here's the angle right here.
I'm so confused right now.
The first one.
Okay.
Yes. Okay. And what I said was, hey, you know what? That looks like an inscribed angle, and it would have to be the arc there, right? But there's going to have to be some limitations on how far out that other ray goes. Because think about this. If I took this and I made the ray go here, is that still the same arc? How is it possible that that angle is the same as the other angle? You see that? Or if I went to here, that's obviously a smaller angle, isn't it? How is it possible that's the same arc? So if we're going to have one of the rays be outside, the maximum it can extend is going to be to a tangent. Okay, so none of these would be considered that inscribed. Okay, as far as it can go outside of the circle, would have to be to a point of tangency, okay? So once that point is tangent, or that line is tangent, then you're good to go. But it can't extend any further. Now that's going to be it right here. So if it's tangent, and that point's crossing there, then the arc is correct. That is going to be inscribed angle. Yeah, if it goes further than that, then it's no longer inscribed. It can't be. It's not possible. Okay, it's not possible. I can't have this angle be the same as that angle, which obviously is bigger. Okay, so make sure that's a tangent line, and then you should be good. Okay. Other than that, you're gonna have to use some of the other rules like you guys did, which was a linear pair and all that good stuff. Okay. Questions on that? Fantastic. Let's move on. So good job on this guy here. Fantastic. These were not angles, were they? These were lengths of chords. So, and they were on the inside. So there was a kind of a product type thing going on, right? And the reason why I want you to do the products is because we're also going to have some other situations or some other scenarios where we've got maybe some secant lines that also cross in some point. Okay, now I won't make the mistake I made yesterday. So we'll say, let's make up some numbers here. Let's say this is, let's call this X, 8, 3, and 4. Is that cool? It look like a little chickadee. So two products here as well, just like it was product from the last one. Here we're going to go outside times the whole thing. Outside piece times the whole thing. Outside piece. Cool. Okay. So we're going to take the outside piece, multiply by the full length. So, shake it up, baby. Oh, come on, no. So, 3 times 3 plus x, because that would be the whole length, wouldn't it? Is equal to 4 times the whole length, which is 12, or 8 plus 4, whatever you want to call it. That's fine. So there's your setup. That's the hard part right there, bro. Yeah.
So it's the length of the outside times the inside?
Times the full length. So it's this outside length which is 4, times the length of the whole thing, which is 12. Just like over here, I've got the outside portion, which is 3, times the full length of 3 plus x. So outside times the whole thing. Outside times the whole thing. And it ain't no thing but a chicken wing. Oh, I gotta look like a chicken. Like a mouse?
The nose.
I know what you're saying.
So, let's go ahead and do this real quick here. 3 times 3, that's 9. That's going to be a 3x. 4 12s is going to give us...
48.
Is it 48? Subtract 9 to both sides. So 3x is equal to... And dividing by 3, of course, x would be equal to 13. And we're done. OTT? Are you pondering what I'm pondering?
Can we do some more examples?
Sure. We'll do a tougher one. You want a tough one?
Wait, don't do it yet.
I can stop singing. I was listening to one of the recordings yesterday, and like you can hear everything I'm saying.
What are you trying to get out of the cap? Oh my god.
It throws inside of there, so it's...
It's a popsicle.
It's getting pretty hot now, huh?
It kind of looks like you're trying to take a puff of your inhaler.
Kind of looks like an adult. It looks like an adult.
Why they were eating an apple?
Come give me some.
Oh, that's in the
No, it's
No.
Yeah.
I thought we were doing it.
That's what I thought it looked like.
Alright.
I'm just following you.
Hi, Matthew.
Hi.
Wait, I'm here.
I'm just trying to look.
Nope. Why?
I don't feel my power. I don't feel my power.
Nope. I know what you're talking about, and we're gonna get to that. So just wait up, okay?
Bigger is better.
You're talking about 2 tangents. So, no, these are not 2 tangents. These are 2 secants. These are 2 secants, right? Yeah, these are intersecting secants, and they're intersecting on the outside. Okay?
Did you hear that?
She cracked herself up.
No, she said a joke. She's like, oh no, she can't. Oh, I get it.
It was good. It was good. It wasn't like funny, but it was funny. I've been doing math for a while, so I've heard of a lot of them already.
Kind of reminds me of your book of math teachers. Yeah.
What?
Your book of math teachers.
Oh, those were good. Okay. Let's take a look at. Let's do something like this real quick here. What were the numbers last time? What was this?
X, wait, that was K.
8, 4, 3, X.
8, 4.
3.
X.
Let's go. Let's do this. Let's call this one X, and let's call this.
7.
Wow. Let's call it 5.
That's an X.
Now it looks just like the last one, doesn't it?
Yeah.
But I've upped the levels of difficulty by like 100%. Actually, probably like 200%. How?
Oh,
Do you see it now? Okay, here's what's going to have to happen. So if I follow my pattern, I got to take the outside piece, so which is x, times the whole thing, which is x plus 5, yeah? Then that's going to be equal to the other part, which is 4 times, what's 4 times 8?
Plus 8.
Oh, sorry, it's plus. I'm sorry, you're right. I was already thinking ahead of this. So this is going to be 12 here. So here's what we got. When you go on this side, I've got to distribute, which means I've got x squared plus 5x is equal to 48. Oh.
What was that thing you were saying?
Wait, x2. How did you get x squared?
Well, don't I have to multiply this out?
Oh, you have to. Okay, never mind.
But that's not like terms, so I'm going to have to use my distributive property here. So x times x is x squared, x times 5 is 5x, and that's equal to 48.
Wait, do the x squared thing again?
Because x times x is x squared.
Yeah, x times x is x squared, x times 5 is 5x.
Can you say the same again for what we have to do for this one? You said.
What is it, guys? Outside?
Times the whole thing. Okay.
Outside times the whole thing.
So you can what's that word? Simplify that the x squared, so then it would go to 5x. Or no?
How would you simplify that?
Squared split it in half, so like there's 2 x's right there,
Well,
and then you add it to the 5x.
but you can't because it's being multiplied. You can't combine those. Those are not like terms. So what we have, friends, is this thing called a quadratic equation. And you have 2 ways of solving this. Okay, now you should already own these skills from last year. So again, there's 2 ways to go about it. I personally would prefer factoring if I could. But if I can't, then I'm going to have to use the good old quad.
Oh, I remember.
Okay? Yeah, good. It's all coming back to me. So, so I've got this bad boy. And what I need to first do, it's already in order. So I need to identify A, B, and C. So A is 1, B is 5, and C is negative 48. And what I'm going to use first is this thing called the discriminant. The discriminant. To tell me whether this is factorable or not. Do you guys remember the discriminant?
Sort of.
It's
coming back.
All right, let me.
Slowly.
Oh, okay.
Huh? I have one from X. Oh yeah, these are the coefficients of those bad boys. Once you put them in order, these are the coefficients. So what's in front of x squared? 1, 5, and negative 48. It goes A, B, C.
I just never called it like that name. They called it.
Coefficients?
Yeah. I just.
Well, we need to be using that vocab. Those are the coefficients, and of course the constant. Okay. All top kids, help me out here. X equals.
Opposite b plus or minus square root b squared minus 4ac all over 2a.
Good.
What the heck? I wish we had a song for that.
Awesome. That's so good. I've hollered at him a couple times.
Is he at?
I think he's.
Oh gosh.
You don't know this?
No.
Okay.
They're all from other schools.
So you follow How Goes the Weasel, and it says x equals.
Opposite b plus or minus square root b squared minus 4ac up over 2a. I don't like that.
I actually have oh shoot, I can't believe I forgot her name. I have some students from last year doing it. All right, so I want to take b squared minus 4ac. Okay. B squared. Do you guys see the red portion there?
Yes.
That, my friends, is a discriminant. That's a discriminant. It's going to tell me whether this bad boy is factorable or not. Okay? So let's start off with 5 squared minus 4 times 1 times negative 48. So I got 5 squared, that's 25. Plus, right? Plus. And what's 4 times 48? 4 times 4, that's 160. 160, 192? That's what I came up with. Is that correct?
Yeah.
Thanks. Plus another 20 fizz that. So it should be 2. I wrote over here. 2, 1.
167. Wait. Oh, I messed up.
217? Now, does 217 have a square root? Is that a perfect square? Gwen?
14.
So it's not a perfect square? It doesn't have a square root, therefore this is not factorable. Everyone understand
So
that?
it's just 217.
So what was, so, huh?
So it's just 217.
Well, I know it feels like we did all that work for nothing, but no. Because what's your second option? If you can't factor it, then you have to go with the quadratic equation. And I already did the hard part of the quadratic. All I need to do is go opposite of b, which is negative 5, plus or minus over 2 times a, which is simply 2. So I've got some of the work already done for me. Okay, so it's not a waste of time. So, what is 5 plus the square root of 217 divided by 2? So what's 5 plus the square root of 217 divided by 2?
Why do we add?
Huh?
Why do we add?
We add and subtract. We actually do both.
But I don't get. Like what? Why would you use that? Plus or minus? Yeah.
You want? You ready for this?
I never.
Okay, so if nobody, you've never used this? Okay, so if you guys don't want to know this right now, then don't listen, but I think everybody wants to know, right? She's asking, why are we adding and subtracting here, okay? Here's what's really interesting about the quadratic equation itself. We know we have a quadratic formula going on here, don't we? And a quadratic formula takes on a shape that looks something like this. So it looks something like this, okay? Now, I really don't know what it looks like. I'll just give you an image, okay? So here's what we're going to do. Let me go to actually explain something to you real quick. So I'm going to start with my grid here. And I don't know if you guys picked this up from Mr. Althoff, but this quotient, that quotient right there alone, is the axis of symmetry. That is the axis of symmetry. So what's negative 5 divided by 2? It's like 2.5, right? Negative. So 1, 2, 3. That means that right here, I have this thing called an axis of symmetry. That means that my parabola, when it comes down, it's going to hit somewhere on this axis and then come right back up. The min or max will be on there. The min or the max has to be on this axis of symmetry. So it's going to be looking like this somehow. I don't know where, but it will be. Okay, that's all that tells me. Now, here's the thing. If I separate this so you can take a better look at it, plus or minus the square root of 217 divided by 2, I've got my axis of symmetry, and I'm adding the same quantity as I'm subtracting the other way, aren't I? Okay, so what is this quotient here? Can someone give that to me? Okay, cool. So that means that from here I'm going to go, I'll call this 0.36, okay? Is that cool with everybody? 1, 2, 3, 4, 5, 6, 7. I would have a point there. And at the very other end, the same distance away, I would have the other point over there, wouldn't I? Let me try to move this over a little bit. So I would have a point there. Now that should make sense to you because isn't a parabola symmetric?
Yeah.
That's why it's plus and minus. We're finding the center point of that parabola, and then we're traveling the same distance in both directions. But these numbers are what we call solutions. Those are the zeros of the function. So now if we have a what do we call it? The minimum, let's say the minimum was here, then I could simply say, oh, my parabola should look something like this.
So, it goes 7 this way, 7 that way.
Right, based on whatever this number is. But that should make sense to you because if I picked, let's say I picked here, the distance from here to there should be the same as distance as it is from here to there. For what reason? Symmetry. And that's all we're doing is we're finding the midpoint, and then we're finding out how far away those zeros are from that midpoint. Okay? But that is something totally very different. It's something you should have grabbed in Algebra 1. We're after these actual values. We're actually after those two zeros. So how much? So you said this was about 7 here? Yeah? So that's about 7. And this is about 2.5. Negative. So if I did negative 2.5 plus 7, that would give me plus 7? That would give me like 4.5, wouldn't it? Something like that. And if I did negative 2.5 minus 7, that would give me a negative 9.5. Now, here's what you got. You have two options for the value of x. Which one is it? The even one. Sorry, the even. I went right after it. The positive one. Why can't it be this one? You can't have a negative distance. So you eliminate that one and you say, oh, that means that x is about 4.5. Now, of course, I'm going with about because we've ended up rounding up those numbers. We're rounding them around. Cool? Let me put the whole thing up there for you.
What about the, wait. Are we supposed to get it?
Oh, did you do that? No. Oh, what's the three?
I thought you did something different. I was like,
I wish I could understand.
Wait, so what if we do like later?
Do you have tissue?
Same thing. Same thing.
there's gonna be a lot of these things in our homework.
Yeah,
Another
because I
song.
was never taught that.
Wait.
No. Because then you're already behind. Yeah?
I'm confused. I thought we were doing the, we didn't do the negative.
Yeah, we did. We added and subtracted.
That's where I crossed it.
Yeah, but we didn't show it.
So here's what you would do. How about some red? You would go negative 5 plus the square root of 217 divided by 2. And then you could do negative 5 minus the square root of 217 divided by 2. And of course, these are approximations because I rounded that off. So you're not going to get those exact numbers. But it gives you an idea of what's supposed to happen.
Are you okay if we round them?
So we always have to do fractions.
Yeah,
I love fractions.
I don't like
Fractions are my favorite.
I'm sorry.
They're the
that's-
mostest
that's
funner
not my
thing I've
opinion.
ever did. Riggs is not easy. Fractions are no fun.
I'm just tired.
I'm sorry. I have to tell you guys, Mr. Trick, you guys know Mr. Trickley, right, principal?
Yeah.
He shows me a little comic strip, and the librarian's like kind of like frustrated on there. He's like, who keeps putting the math books in the horror section? I thought it was so good. That's what I like about the ice in there. I feel like I'm gulping there. Yes. It's called the quadratic. What? What's up, Rick? Guys, I can't hear. Go ahead.
Can you show us an example when it is factorable? Just so we can go over that.
You don't remember how to factor? Okay, that's okay. I mean, I can do a little quick sum on that. Let me get through the circles first, and then we'll do some factoring stuff. You know what? Let's do it now. Why not? So let's say I ended up with something like x squared plus 5x plus 4 is equal to 0. Okay? actually, can I show you from the very beginning? Because every operation has an opposite operation, right? An inverse operation. Okay. So let me show you the inverse operation first. I'll save that one for a little bit. Let's get two binomials up here. X plus 3, x plus 4. You guys remember how to do some binomial expansion, right?
Yeah.
Good. Because factoring is simply the opposite of that. So looking at this, you should say, oh, well, that's just x squared plus 7x plus 12. Yeah.
Wait, are we using that one or before?
We're going to do this one. We're going to save the other one, okay?
Is it not yet?
It's just FOIL, right? Okay, I hate and love that word. Look, for those of you that don't know how to do this,
First, outside, inside.
everybody,
This is what you get for missing the whole year.
Brianna, you know how to distribute, correct? Okay, so let's start by distributing just the first item, okay? So x times x would give me, right? We're good? Let's do it to the other one now. So that would give me a positive 4x, right? Okay, cool. Now that we did the first one, let's do the second one now. 3 times x is 3x, right? And 3 times 4 is 12, right? Now, what they're talking about, which is kind of annoying, but it's still useful at the same time, they say, oh, it's just FOIL. Well, what did we just do? We just used the distributive property, didn't we? Guess what we just did also? We just FOILed. Okay, we took the first one times the first one. Then we took this inside ones and multiplied them, didn't we? That's I. Then we took the two outside ones and we multiplied them. Oh, wait a minute. No. Did I do this backwards?
Yeah, see how you did
Sorry. I didn't even follow my own order. We did the first ones first, and then we did the outside ones. Okay, and then we did the two inside ones, and then we did the two last ones. And that's FOIL right there. They call it FOIL. But it's just the distributive property. Okay? Now, what I did is I practiced so much where I can see what's going to happen is that the two middle ones are going to end up adding, so I'm going to get x squared plus 7x plus 12. You need to be able to do that. If you cannot do that, you're going to hurt a little bit more when you're factoring. So, if I give you something like x minus 3, x plus 5, it goes like this. Now, I'm doing FOIL in my mind. Okay, the first one's x squared. But then here's what I do, people. The outside plus the inside. So all I'm really doing is combining these two. What's 5 minus 3? That's going to be a 2x. And then I multiply these. That's a negative 15.
Wait. What?
That's foiling. I just foiled it. But I'm showing you what I do so I can get to the answer fast. Okay, because this is simply going to be a 5x, right? And that would be a negative 3x. So what's 5x minus 3x? 2x. And then that times that is negative 15. See that? You cool with that? How about now? What is this, people? X squared.
Minus 4.
Boom. There it is. Okay. So the two numbers that I picked, what did I do with them for the middle one?
Yeah, just add it.
I added them. And what did I do with those two numbers to get the last number? I multiplied. Well, guess what? Is that a question, Jake Walden? Okay. So this is very important to know because when I'm going to go the other way, what do the two numbers I pick have to do? They have to multiply to this one, add up to that one. So if I go back to here, what two numbers multiply to a 4 but add up to a 5? So that's going to be x plus 1 and x plus 4. And if you want to check it by foiling, x times x, that's x squared. That's 4x, 5x, that's good. 4x, we're good to go. That's it. But now you know. And knowing is half the battle. G.I. Joe.
No, like what I meant was like, you know how you were saying that like, is it factorable? Like over here, we had to do the negative b equals the b squared. Like what happens like in 217 had a square root?
Then you would just know to do this. So, for example, b squared minus 4 times a times c. That's a b, right? So that's 5. That would be 1 and 4. So 25 minus 16 is 9. There's a square root of 9, which is 3. 3 has nothing to do with the factoring of this. All I know is that this is factorable, and I can factor it.
Oh, I see those.
That's all it's telling me.
Alright.
The fact that the square root of 9 is 3 will not help me here at all. All it's telling me is I can factor this bad boy.
Oh,
Okay?
I got
So, but once it's factorable, does that become x?
No. That's only the square root part. So, I mean, if you're going to do this much, then go ahead and finish up with the quadratic, right? Because once you know that that's 3, then all you need to know is, oh, opposite b, plus or minus 3 divided by 2 times a. So negative 5 plus 3 is how much? Negative 2 over 2?
Negative 1.
Wait a minute, should that be, did I do this correctly? Yeah, plus or minus. Okay, so negative 5 plus 3, that's negative 2 over 2. It's a negative 1, so x equals negative 1. And x equals, let's see, that's going to be 8, right? Negative 8 over 2, it's a negative 4. Now, that doesn't look like what I factored, does it? Yes, it does. Okay? Yes, it does, because here's what I want to do. What did I say when it was in factored form? It was x plus 1, x plus 4 equals 0.
Yeah.
Man, I'm teaching something totally this is like upper math, but that's okay. We're going to get through it. So here's what I do. How can I move this one to this side? Add it to both sides?
Yeah.
So that becomes x plus 1 equals 0. And this would become x plus 4 equals 0. Well, if they both equal 0, then x plus 1 and x plus 4 equals 0. There's our factored form.
This is like the whole like old.
I'm so sad. That's my favorite one too.
Should just drop it. Yeah, it'll be okay.
No, here we go.
See if it still works.
No, it works. It just fell apart. There you go. Gotta drop the mic. All right, cool. Are we good?
Drop it again.
No, I'll drop this one. I've dropped those many times they don't break. But I forgot this was like a more advanced.
Why is it more advanced?
It's made in pieces, so it's got the hard plastic, and there's hard plastic at the top. But there's this black ring around here. You guys see that?
Yeah.
And this is actually meant for a newer smartboard, because the newer smartboards, this is like a big mouse pad. But a newer smartboard is not. It has sensors all the way around the edges. So it has little lasers that cover the whole surface. So as I put this marker in, the lasers hit this and bounce back. And that's how the software knows where you're writing. Well, what's the purpose of that? Well, if I've got sensors, then I can touch at 2 different points, and it's multi-use. So I can stretch, shrink on a new smartboard.
Oh my.
Not with the old ones. Now, if you guys want to see a new smartboard, Ms. Casabuena has one, and Mr. Shapiro has one. Sad face.
Why don't you have? Wait, why do you have that?
Because I can't be stingy. I can't take all the good stuff for me.
You said you can't.
I could, but then I would be like,
Everyone would hate
Windows
you.
is a jerk. So, and I do fine with this one. It's cool. At least I've got one, right? I know. Windows is a jerk. They're like, do me a favor. Call me jerk one more time. I like that song. That was so good.
When you drink that stuff, won't it be all like watery?
Okay. So are we good here, Riggs? All right, cool. Now, I want to show you guys some more circles. I want to show you guys this scenario right here. Point of tangency, 8x 5. Do it. Find me the length of x, please. The big circle?
Yeah.
You can if you want to. I'll get it up right.
Or are you
I'll
teaching
put it up
us
on the
stuff
screen.
right now?
Yeah.
Is the
Yeah.
point of tendency 180 also, or?
Thirsty. Someone pay me attention.
Would the point of tendency be 180 also?
What does that mean?
Or the, like, no degrees on there. So we have two mystery numbers?
No, there's only one. X.
But you need the that as well. How much is the point of tendency? Then,
I finished.
You guys want me to make this a nicer number?
wait, if the point of tendency is 0, can I make it 0? Can I make the point of tendency 0? This is only two numbers.
Okay, then erase the rest of this. I don't care about this piece of it. It's just that. That's all that is. I just don't draw perfect, bro. Bro. So wiggly. It's like so wiggly. I had a student that when she got blocked, she would go math.
Did it work?
She said it did. So she would just like try to put her mind in math mode. She'd be like math.
Every day
I was weak when she told me too. Exactly what happened to me. You guys gotta start that trend. When you're focusing like math.
You don't even have to be in that.
I know. You be in Spanish, be like math. Matemáticas.
Us during finals.
You guys are too funny.
Dead silence.
OTT. You're making me sad, brother. Oh, I didn't know that. I'm sorry. What's wrong? I don't think you can contagious right now.
Okay, this it's 22
That's the word.
3.142.547.143.
Not you, just your disease.
Oh, wait.
Wrong.
Don't go
Fine.
I messed up.
Okay. Here we go, children. Not yet? That'd be cool. dogs and 2 children. Okay. Time. Let's go over this. Outside times the whole thing, which is 5 plus x. That equals the outside, huh? Times the whole thing. So 25 plus 5x is equal to 64. Take 25. What are we at? 39?
Yeah.
Sha? Sha.
Oh God, no.
Why do so many for?
Oh no. From the other segment? Okay, questions on this example? One more.
Is it gonna be like that one?
It's going to be exactly the same but different.
Exactly.
Oh, okay, but you went
Well,
to
what do you do?
No, look at it as the same, but different.
You can't do that.
Oh, are you playing the circle game again?
What circle game?
It's a.
Yeah, the circle game. You make them look at the circle. You make them look at the circle.
Oh. I'm really
You
good.
can't do it above.
It's got to be, yeah.
But it's not above, it's at level. Exactly. But my hand, my arm, but my hand.
His waist or his hip? Because you're pointing way down there. Oh, there you go.
How about when they're both on the outside, peeps? Find that one.
Oh,
Ain't nothing but a party. Five?
just hate dogs.
You don't have dogs, you have a cat, bro.
I got it.
Did the answer surprise you?
Not really. I don't even know.
It's just 5.
Oh,
It's 2 intersecting tangents. However, in case you did forget that, but if you did forget that and you try to do the math, x times x is equal to 5 times 5. X squared is equal to 25. If you take the square root of both sides, x is equal to 5. But we knew that.
Okay, so
That was so good.
Can you, so if they're intersecting again, then they equal the same?
I think we said that at the beginning, right?
I'm just I gotta make some notes. I remember when you wrote that and you looked at it.
Outside times the whole thing is equal to outside times the whole thing. Anybody know Priscilla? Oh, you know what? Let me end this now. Because I got a name for her. Purple rain.